Welcome to Module 7, the Programmer's Toolbox. So we're going to start with Python. You did get some exposure to this in the previous module. And what I previously explained is that in Python we're actually working with what's called a data frame, right? So this is basically the equivalent of a data set, or similar to how you would view data in a spreadsheet, right? There's columns and rows. In SQL, you can think of this as a table. In R, it's actually called a data frame as well, right? So R is another popular language for data analytics and data science. But as you know, we're going to be focusing on Python. So in Python, there's actually different data types. I mentioned earlier that the type of data that you have, or the column type, is important, right? So what does that data represent? Is it a number? Is it a category? And you can see there that there are different data types that are numeric. So int is integer values. Float would be something with a decimal, and then complex numbers are a variation, right? So it has kind of both a number and then potentially a character in there. So those are complex numbers. And largely you'll see just the integer and then the float in the data that you are looking at or analyzing. You can see some examples there, but with categorical, there's string values, also Boolean, so kind of binary categories, or true, false, or yes, no, you can think of as a Boolean. Object, so those are often storing categorical or mixed types. And then finally category, that would be in pandas, right? So that would be used specifically for categorical data representing fixed groups. So there's a number of different operations. We're focusing on pandas, as I mentioned, as that's the library that you'd use to analyze data frames. So the thing about pandas is that you first need to get it into a data frame. So we're going to read data in, or import the data. And this reference to PD, that's just a reference to the library. So usually when you import this library with all these functions, you say import pandas as PD, so it's just an acronym or reference. So you can import data of different types. If you want to inspect data, there's some nice functions for that as well. Also dealing with missing values or imputing values. Additionally, you may need to filter or select data, and you can see some example code there, right? Selecting columns, multiple columns, filtering rows. Additionally, you would potentially need to transform data. So suppose I want to rename a column. You can see that there are some nuances, right? So you can kind of see that I put the old first, then the new name next. If I want to add new columns, I can do that fairly easily, or combine columns. I could also drop columns as well, right? So maybe you have a redundant column, you want to drop it, or you don't need it for your analysis, you may decide to drop it. Removing duplicates, right? And again, one of the things that I want to point out is you have the df. Df is reference to a data frame. You can call it whatever you want, but you can see that reference there, and then a period, and then the function that's shown there, right? So whenever you see df or data frame, that's what we're referring to. Yeah, you may need to standardize data. Additionally, you may need to aggregate. So you can do a kind of collapse summary of your data, maybe by a category or maybe by a group. In that setting, you would use group by. Additionally, merging. So merging different sources by a common variable, or you actually may set data together as well. Reshaping, so you may want to kind of transpose the data. Additionally, you may have dates. So working with dates, you may need to convert that column to a date, so a date format. And you can also generate sort of certain periods, such as a year or a month. Finally, once you've done your analysis or sort of processing, you may decide to export it. Additionally, you could actually upload it back onto, if you're using BigQuery, you could upload a new kind of table to work with, or a clean table to work with. So if you go back into the tank, right, so I have the data processing notebook here. Let me actually open this guy up. And what you can see here, I'm still going to use the sort of same logic. I'm going to pull this data directly from the web, so I'm going to import that pandas package. There's a couple other packages here that might be useful, so we're just going to import those in, and then we'll get our data imported as well and saved as a data frame. So you can see the first section, they're loading and inspecting, so I'm just going kind of in sequence as you would with potential analysis. You can see here I'm just printing the data, right? We've seen that before. Head is going to give me the first few rows, right? First 5 by default. And I could use tail, so tail would be the last 5. Info is going to give me information on the column and the column type, as well as the count of null values, or how full the data is, or how full that variable is. Additionally, summary statistics for any numeric columns, so you can kind of see there, right? My average viewership is about 4.97. I'm just looking at this guy. Median is about 4.65. You can look at the the valuation column as well. So this is actually scientific notation. So if you wanted a fuller view of this, you would just be able to sort of plug that value in. So let's go ahead and just copy. Oops. This shows you kind of what scientific notation looks like, right? After it's sort of been reprinted, and you can kind of see that there as well, right? So I'm going sort of 6 decimals to the left of this one, right? So you can kind of see the full number, right? So that means that the average valuation requested is showing up here as 3.6 million, right? 3.6 million. Okay. Shape, so dimensions, so the data frame shows you the records, number of columns. So if I need to deal with missing values, right? I can do that. And just for curiosity, let's actually print the max valuation requested. Yeah, so you can see there that's suggesting to us that 100 million was the max. So that's something I would probably want to look into. Right? What's the context there? What type of business was this, or what type of pitch was that? I would want to see if in fact that's a legitimate value, right? Legitimate value in our data based on reality. Okay. And if I can then see they're handling missing values, right? So I might check for missing values. You can kind of see the count of missing values for each, right? So the season number is always populated, or startup name is always populated. And suppose I wanted to fill in missing values, let's say for the deal amount. So if I fill in missing values for the deal amount with 0, and that's because I know that for deal amount, when it's missing, in fact, that individual did not get a deal, right? Or the pitch did not get a deal. So I would always kind of want to check to see what that looks like again. So if I just type DF, you can see if I go to my data, well, it doesn't give me the full view, right? But let's kind of see. What I could do is, if I want to get a full view, I could produce an interactive table, and it gives me a little bit better view. So let's kind of dig here. Yeah, this is showing all of your pages, right? So different pages are going to be corresponding to different different records. You can see by the index number or the observation number as well. All right, so that is a little bit helpful, but I'm still kind of digging around, and if we see here, so we want to look at deal amount. It's not easily visible there. So what I might do is actually just select that one, or that specific variable, and you can actually see that there's a warning, max columns is 20. So if I plug that in and just look at the deal amount, whoops. Let's see if we can print this. Huh. Let's check if it's still there. I see. Well, one of the things that we notice here is that, in fact, the deal amount is not a variable in this data frame, right? So what we actually see is that total deal amount is the real variable, or real variable name, and we used deal amount, right? Deal amount. So this actually is checking to see if deal amount is in my data, then fill this in with zeros. So in fact, we made no changes to the data frame, and that's what we can see here. That's where we got that error message when I tried to print that specific column. Okay, so that was maybe a learning exercise, a good learning exercise. So we can see then, though, that if we have specific variables that do correspond to a legitimate column in our data, which, with the deal amount, it couldn't find or couldn't replace those missings with zeros because it doesn't exist, so it didn't show up in our sort of edited data frame, or would have been edited data frame. But you can kind of see, if we keep going here, I can look at the got deal, right? So this is a column in our data frame. So got deal, and yeah, so this is the correct variable, right? So I'm going to select two columns, total deal amount and then got deal, and you can see that in this case there's still these null values because again, those are records where that specific pitch did not get a deal. And you can see that, side by side through that with that Boolean or that 1-0 indicator for got deal and then didn't get deal. Yes, we want to filter to those that actually got a deal, right? So the got deal greater than 0, we can kind of see those records, right? 844 rows or 844 records or pitches that got a deal. And then maybe we want to do some sort of multiple conditions, and I can see that I can pull a got deal and also the season number as well, right? So just season number 15 or 16, right? So equal to 16. And you see that this double equals sign, so it's kind of a kind of particular thing with Python in which when we're using that condition that we're trying to apply, that we need to use that double equal to say, hey, pull pitches that are from 16 or season 16. Additionally, we may transform. So we might rename some columns, right? So we actually, if you go back to the info, which is pretty easy to do, and look at those column names again, you can see that I actually changed the name to company versus before it was startup name. I can add new columns, so I can do maybe a percent of ask, right? So total deal amount divided by original ask amount. And I may drop columns like the company website. And then you see our adjusted data frame here, right? So I get a new view or a new peek of the adjusted data frame. Could do some cleaning. Maybe want to see if there's any duplicates. I know that they're not, so that's a note there if they occur. And you can see that no records were dropped, right? Our data frame is still in the same count in terms of number of records, or at the same count. And then if you want to peek at the records again, you can take a look. But one of the things we could also do is kind of standardize text. So this is actually changing the business description, so it's lowercase, and also stripping any white space if it occurs in the data. And then when we see here, when we get to the aggregation grouping, what you'll actually see is we can actually group using all of the numeric columns, right? So we're going to select all the numeric columns based on this condition, and then do a group by and calculate the average, right? So this is actually the average by industry, right? So group by industry, and we selected just the numeric columns, and then we're calculating the average, right? So you see that average function at the end. So it kind of shows us some interesting things, right? We can see across industries all the numeric variables and their average, and you can kind of see if you look at like maybe the original ask amount, right? So the average is about 226,176 for automotive, and so interesting. It's actually over $483, or sorry, $483,000. $483,000 versus here, it's about 226,000, right? It's 483,000 versus 226,000 for automotive versus green and clean tech. So you could get some similar comparisons, right? Obviously, though, we would want to eventually test for statistical significance, which we'll actually get to as well, to see if those differences for any of these numeric fields might be statistically significantly different based on a category comparison, similar to the one that we just did kind of casually looking at the average. We can also look at sort of aggregating for kind of several columns, right? So it sort of shows you the sum of the total deal amount, also the average valuation requested, right? So we can kind of look at some differences and see if there's some insights from comparing these categorical descriptions. In this case, it's industry. So additionally, we might merge or join. So what I'm installing here is there's actually some data I'm going to pull in from the web, and what I'm going to do is actually merge by date. So I'm actually going to convert a field to a date field, and this is the original air date. So what we'll do is actually we'll get unemployment rate data, and it's kind of a it's a sample analyses or sample merge. But suppose I wanted to merge on unemployment data by date, right? So you may not actually study some of this, but it's just showing you that you can actually fairly easily merge data based on common fields. So what we're going to do is we're going to take this unemployment data and we're going to match the unemployment rate closest to the Shark Tank episode air date. So we'll go ahead and merge that. And again, it's based on month. So this is actually based on month. And this is a merge, but it has to be the case that the month appears on both data sets, right? So we call it an inner join, right? So they have to match or sort of overlap. So we're just including or saving the overlap. So we'll drop that column and then take a look at that merged data set there. And you can see the unemployment rate's actually at the bottom there, right? At the very right. I want to say bottom, but it's at the very, very right of the data frame. And you can see the unemployment rate associated with that particular air date or close to it. And you could use that for insights. You could see if there's any sort of correlation between any of these variables. But that would be maybe something you wouldn't study, but it's just interesting to see the actual merge. Maybe you have some additional variables you might come up with and want to merge on to see if there's any correlations or any relationships between any of the variables that we do have. So back to our sort of original data frame. Again, I can kind of look at all of the columns and the variable types. In fact, you can kind of see that there's that month variable we just created at the end there. But if we look at the sort of pivoting and melting, we'll look at that pivoted data set. So what we did here is we actually went with a summary by season number, right? A summary by season number. So you can see the different industries, and the variable that we used was total deal amount, and then we actually took the sum, right? So you can take the sum of all the deal amounts across the season by the industry, right? So this is the columns is the industry, and then the index is the season number here, and then the values that we used was total deal amount, and then we took the sum by season by industry. So additionally, you can see that I can also melt that data or melt that pivoted data, and you can see that I'm basically putting it back to long format, right? So I'm putting it back to long format, and you can see that the industry is now shown up there, total deal amount. So this is showing me every season, right? And then the industry for every season, and the total deal amount. So that's sort of in long form. So finally, I could export this data. So if I hit export, let me go ahead and hit that. And you'll actually see here that it's actually shown up here, so I could actually download this as well. But you might actually want to upload that onto BigQuery or save that onto BigQuery, or create a table in your data set. So let's go back here. So what we'll transition to is SQL, and let me go into slideshow here. So in terms of SQL, basically for SQL, we're working with tables, right? So there's actually tables, there's sort of like Excel spreadsheets, and so that data set that we just worked with, or that data frame we just worked with, is actually a table that's also uploaded onto BigQuery, or I'd uploaded earlier so you could work with connected sheets. So queries, we can ask questions, right? Think of it as a sort of web search engine. So we can ask business questions and query and get results and see the records. We can actually summarize data as well and do calculations, similar to what we did just now in Python. But with crude operations at the end there, you can see we can create data, we can read data, also update data, and then delete data. So SQL queries can actually get very complex, but there is actually an order, and so you can kind of see this structure here, right? Select from, where, group by, order by. So select is basically we're going to specify what columns we want to select. We also might create columns in that step. From, that's where we specify where that table is, or where the data lives from that specific table, right? In this case, my example is I'm selecting these columns, but I'm actually creating some columns where I'm counting the number of pitches, the total deal amount, sum, the average equity, and then from this table, and then finally, based on this condition, right, where got deal is equal to 1, I'm grouping by the industry, and then only keeping industries with deals or greater than 0, and then ordering by that total deal amount. So this is basically if we wanted to analyze the total amount of deals secured by startups in each industry, their average equity offered, the number of pitches per industry for startups that received a deal, and then we're going to sort the results by the total deal amount in descending order. So obviously there's a lot of resources for SQL in terms of structuring queries and the sort of order of queries and what can be done. But we're sort of getting a good peek or preview. Certainly if you want to dive deeper into SQL, that's certainly possible. But you can see that with the explanation, it is actually very helpful within BigQuery to know at least some basic SQL, so you're not pulling your data set out into Python every time and just kind of working within that environment and doing sort of quick searches on your data set. So this sort of gives you the detail. I kind of already pointed all this out, but you can kind of see that we have some specific variables we're creating up here, but this gives you sort of a line-by-line rundown of what every piece of code or line of code does. So you can see that this might be a hypothetical table output, but what I can do is I can actually run through this myself using our own data. So let's go ahead and pull that up. And the last thing we'll see is if I go ahead and run that. So again, I'm going to pull in my data that we've just seen quite a bit. I'm going to use SQL. Oh. And in fact, it's another learning point. I actually do need to import this package, SQLite 3, and let's see if that, okay. So importing that library, establish a connection. So I'm writing the data frame to SQL, and then I can then verify that this database has been created. And then finally I can check the variable names, and you can kind of see that I can go ahead and sort of keep going and sort of run my query. But this sort of shows you that process, right? So I've basically connected to that data and am able to use it now. And so I'm actually relying on this package, this library, SQLite. So just loading the data onto SQL. So then I can actually query the data. So this is just a basic query. We're going to select, when you see that star, it means everything. And then I'm going to limit it to the first 5 records. And if I print that result, you can see I do have the first 5 records. In this case, I still have that company website variable there from the original data. So finally, let's run our query that we just discussed, and we can check out the result, and then it gives us a nice table at the end, right? I have the by industry, number of pitches, deal amount, and then average equity, and obviously I'm sorting by the highest total deal amount. So food and beverage is at the top based on 183 pitches. You have the total deal amount and also the average equity as well. So finally, I can actually run that same query directly within BigQuery. So for time purposes, I've actually saved that. So there actually is a query. It's exactly the same. And you can see there that, yeah, maybe there's a couple different nuances that I may have had to sort of adjust my code a little bit to account for. But you can see that I can run that same query, and I should get the same results, right? Yeah, so you see that that same table. So it's kind of nice because I'm staying self-contained into in BigQuery, whereas here I actually had to create a SQL connection, and then I could then run queries and query directly. You can also use Colab to connect directly to your data that's stored here, right? It's stored here. That's another option as well, but this kind of gives you a one-stop shop to sort of go ahead and run various queries, and you can actually save those as I just done in mine. In this case, I call it Shark Tank Summary by industry. And so with that is our sort of coding review and the end of Module 7.